I'm Jamie Panagos. I work for Charter Communications. We're a large MSO here in the United States. We do video, internet service, phone, all those sorts of MSO things. But another thing we do is deliver IP video. So we're going to talk a little bit about our road to where we are today, and then some of the stuff that we're thinking about doing in the future that I think is pretty exciting. So current environment, we run our own IP video CDN that we built in-house. It's an Anycast-based client routing model. So what that means is the CDN nodes advertise reachability to different IPs to the network, and the clients try to go to those IPs. So there's no centralized control plane for the CDN. There's no intelligent brain in the middle that knows about the status and routes clients and knows that this client's in Florida, so I'm going to route you to the Florida CDN edge. This all happens without that central control plane. The way it works is there's a CDN hostname, cdn.charter.com, and it resolves to a bunch of different IP addresses. Because there's a number of those IP addresses, let's say 10, it's 16 in reality, but 10 makes the math easier. If you assume that there's 10 of them, each one is handling 10% of the traffic. So you get a statistic distribution across those 10 IPs. So you're getting dynamic distribution there. The CDN nodes that are allowed to serve the content that's being requested advertises those IP addresses. So you have the client resolving to any one of those 10 IP addresses, and you have a server over here advertising those 10 IP addresses. And that's how we do the client routing, so there's no centralized brain. We use BGP for that, which is a routing protocol. It's one of the most popular ones on the CDN today. And then to make sure that each one of our edge nodes takes an equal amount of the traffic, we use what's called a med. It's just a metric. And we tell BGP to use that value when it announces the route to the network, and that spreads the load across, let's say, 10 nodes. So node 1 would be primary for the first IP address, node 2 for the second, all the way through 10. So we have DNS doing distribution, equal distribution of clients to IP addresses, and then we have BGP used to draw the clients to the best node for them. This gives us some advantages. One is because there's all those IP addresses, we can use that fact to start reducing load. So if a server gets overloaded, instead of announcing all 10 IPs, maybe it only announces 5. So now I can dynamically adjust that load on the fly just based on the number of routes I advertise to the network. Another benefit of it is because there's no DNS involved, I don't have a DNS stickiness problem. We've run other CDNs, and we've found that some clients will hold on to resolved IP addresses for up to a half hour. So if that node goes down, you're down for a half an hour. With this model, there's no DNS stickiness, so it's impossible for that to happen. Another advantage is failover is node and network sensitive, and what that means is if the network has an issue and links go down and I don't know, they're doing maintenance, any of those sorts of activities, because the network has changed, that naturally pushes traffic away from the CDN node. So there's no competition between the CDN and the network. They're very interrelated. Everything we do is done through a RESTful API, so there's no manual configurations. It's all automated and done through a RESTful API. And then as you go up in our CDN, we have an edge, we have an aggregation tier, we have a mid-tier. It's the exact same logic, just different Anycast IPs. So the clients have a range of IPs that they use to get the edge. The edge has a different range of IPs that use to get to the mid-tier. Same exact concept, though. So we replicate that, and we can go as many deep as we need to. This is the crash course. There's a lot more to it, but you get the idea. So this is what I was just talking about. So basically, we have, in our national data centers, that's where our content actually lives, and those are geographically diverse. Those advertise a block of Anycast addresses, and then out in our field, out in all of our POPs out in the field, we have aggregation tiers and edge tiers, and those use each of the tier above them to get content. So basically, if a request comes into the edge tier, it checks its local cache. If it doesn't have it, goes to the next cache. If it doesn't, goes to the next cache, and eventually goes up to the origin. But the main point here is just different tiers using different Anycast addresses, but it's the exact same model at every tier. There's nothing special about any of those nodes. So like I said, we built our own, so we looked around to figure out what sorts of things we needed to do to build this. So it's all based on CentOS. Nginx is obviously the caching daemon, probably wouldn't be here otherwise. Bird is the routing daemon, so that's the thing that interacts with the network. So that's the routing daemon. And then we have this little thing in the middle called the health tracker, and what the health tracker does is it's constantly taking taking a scope of the node's health. Do I have, am I going through my RAM? Do I have a CPU problem? Am I taking too much traffic? Do I have a hard drive failure? All sorts of stuff. And that's what tells Bird how many routes to announce. So if I'm really sick, I might advertise no routes because I don't want any traffic coming to me. If I've lost my hard drives, or if I have a bad DIM, or something is wrong, I might take myself out of service entirely by withdrawing all of my routes. Or I might say I'm about healthy, but I'm a little bit overloaded, so maybe I'll only advertise 8 of those 10. That's what the health tracker does. It does all sorts of checks and comes out with a number, and that's how many routes you advertise. What you end up with as a result of this is a self-leveling system. So if I'm a CDN node and I'm overwhelmed, I'll reduce the number of routes I'm advertising. That traffic has to go somewhere. It'll go to another node. If that node's overwhelmed, it'll go somewhere else. And eventually, assuming you have enough capacity in aggregate, it'll find the node that has that capacity available. So you end up with this self-leveling system. Anything else? That's about it. All right, so why do we use Nginx? We did a bake-off between Nginx and a few other popular caching engines. Some didn't get through our performance requirements. We had pretty strict performance requirements because we're delivering video. Some of them just didn't pass those requirements. Others failed resource utilization requirements, so we had very specific, you have to fit into this box, this much RAM, this much CPU, all those sorts of things, so others failed there. It came down to a couple of the caching engines, Nginx being one of them. And really the decision came down to the configuration simplicity, the configuration readability. That was huge for us. We wanted a human to be able to look at that config and say, I understand what's happening. Some of the other caching engines didn't have that benefit. And then also the resource footprint is obviously very good with Nginx, so we didn't have to spend a lot of resources running the daemon. So we've gotten up to 50 gigabits per second. Actually, a little north of that, I think we had about 52 gigabits per second per node. And these are 1 RU servers, so that's pretty decent density there. We hit 1.5 terabits per second pretty regularly now. That's a little outdated. That used to be our high water mark, but we're hitting 1.5 pretty regularly now. Our largest chunk, which is 3.4 megabits per second, it's a 6-second chunk, so that's about 20 megabits. We serve at about 600 milliseconds on average. By doing this, and this is obviously the business portion of it, is we reduced our control plane cost by 100% because there is no control plane. We reduced the mid-tier cost by 75% and the edge node cost by 60%. So it was pretty decent savings. And as the cost compression of commodity hardware continues to drop, those numbers just keep on getting better and better. Operating costs were very similar to what we were paying for the commercial CDN support that we were getting previously, so kind of a net there. And the last one is my favorite, is V6 out of the box, and we got 33% penetration with V6 the day we turned it on. Hasn't gone up much, but still, I'll take it. Okay, so that's kind of where we are today. We have the CDN that kind of interacts with the network, but not as thoroughly as we would like, but it works. Then we started to think, okay, how do we make this better? What things can we do to continue to converge the network and CDN? And we came up with this concept that we're calling resource routing. So like I said, we've gotten pretty far with the CDN that we've built, but the route advertisements represented an arbitrary but large thing. In this case, it's video resources, but it could be anything. And in our case, we represent one type of video, which is linear, live video, and then another block represents VOD. And that's about it. That's the level of our granularity. It's not CNN or the Game of Thrones episodes that's coming out tomorrow. It's all of our live video. So it's not as granular as we would like. And what we found there is, if you really want to get smart about business level decisions and technical business decisions, you need to get deeper than that. It can't just be a big block of stuff. So we started to think, well, how do we continue to converge that? And we started looking at BGP and V6 and the combination of that, because there's infinite V6 addresses. Can we start using that as the thing that represents content? Rather than having a block of addresses represent all of this content, have a single address represent this single piece of content. And then can we start using BGP to communicate that? So that's kind of where we started on this. The proof of concept goals that we came up with at the beginning is we want to associate a resource with a v6 address. We want BGP to convey that reachability. We want the CDN to actually consult that BGP routing table to figure out who's telling it that they have that content. And then use that as the upstream to do your backfilling. So if you get a request in, rather than having a static configuration file that says, go to this upstream, I want you to look in this routing table to figure out who your upstream is. And that gives us all the dynamics that we're looking for. We use this for ABR video because that's what we're doing today, but the concept is resource agnostic. The thing that you're going after doesn't have to be a video file. It could be anything. So there's a lot of benefits to this that we've found as we've gone through the process. We get upstream liveliness detection because if BGP goes down, you've lost reachability to that node automatically. So you know that your upstream is dead if your BGP session goes down. So you immediately get that information. You don't have to have a centralized control plane telling you. You don't have to wait for a ping timeout or a health check failure. You know the second that BGP session goes down that you can't use that host anymore. Also provides a nice way to take it out of service. You just shut down the BGP session or kill the BGP neighbor. That node's now out of service immediately. That was the next one. Kind of got ahead of myself there. Provides intra-CDN resource auto-discovery, and this is something that we're really excited about because right now, if we bring up a new origin, we have to go in and configure Nginx to point at that new origin. We have to say, for this URL, manually type it in, go to that origin. With this idea, we now end up with a concept of auto-discovery. When that origin comes up, advertise your BGP routes, and the CDN now knows where to get that content automatically. I don't have to go in and type it. It's self-discovery. This is where things start to get a little bit interesting. It could provide a vehicle for inter-CDN resource advertisement. And what I mean by that is, right now, if I want to share resources with another CDN, again, we have to have an agreement. I have to go in and tell them, use this as an origin. They have to go change their configs or vice versa. The same way that I was talking about doing that auto-discovery within a CDN, you can now do that between CDNs. So if I run a BGP session with a neighboring CDN, they can start telling me about content they have, and I can start telling them about content that I have, and now we can start sharing that CDN resource. And there's lots of stuff that comes with that. BGP by default wants to get the packet off of its network as fast as possible. So you get shortest routing by its nature. There's all sorts of traffic engineering things you can do. I mentioned meds before. Local preference is another one. There's AS path prepending. All these things that network engineers have been using to engineer the way the internet works, now you get on a CDN. And it's also a lot easier to go find network engineers who know BGP than it is to find CDN engineers who know how to do this. Right? I can go get people pretty easily who know networking. And then communities. Communities are a pretty interesting one. So communities, for those who don't know BGP, are arbitrary tags that you can put on a route. They don't mean anything to the routers. The routers don't care about them, but they mean something to you. And it could mean this route comes from Chicago. It could mean this route is for video. It could mean anything you want, but it only means something to the people who know what it means. So it's arbitrary. You make it up. If you start using this for CDN sorts of things, you can start thinking of communities that do things like, please purge this from the cache, or please don't serve this anymore, or please only use HTTPS to serve this, or please don't serve this to customers in Europe because we have regulatory rights on that, or something like that. You can start encoding information into your control plane immediately, and you can change those whenever you want. So I can advertise you a route saying, I know how to get to this thing. 5 minutes later, I can send you another route with a community that says, please purge that. So I can do that anytime at my will, and it puts the control of that into the originator. So I, as the originator of content, can say, oop, purge that, that was bad. So that's a really interesting concept. We'll talk about that more as we go. So in that model, the thought is, right now, if you're a service provider, you go to a registry and you get address space. You go get your large block of address space that you're going to use for your customers. Same concept here. If I'm a CDN operator, I can go to one of the registrars and say, I need a block of IP addresses, and I'm going to use that specifically and exclusively for this CDN concept. And then that provider can start allocating those addresses to whatever they want. In our case, it would be video, but it can be anything. Another nice part about routing is inherently hierarchical. So there's a network can be fit into a larger network, can be fit into a larger network, fit into a larger network. So rather than having to advertise all of my individual video routes to another CDN, I can advertise the large route in one foul swoop. So that cuts down on the size of the table, which is really nice. All of this is the way the IP network runs today. We're just now taking it and starting to think about it as a use case for CDN. One other advantage of this is what we're calling cache scoping. And the idea of this is all content is not created equal. Some content is much more popular than others. However, in a generalized CDN, a thing that gets asked for once can take up just as much space as a thing that's asked for 1,000 times. Caching is an expensive resource, so you want to reserve it for the popular stuff. So one of the things you can do, and I have this on the next slide here, if you start to think about the concept of setting what's called a BGP Next Hop, you can prefer to cache that content or not. And what I mean by that is, if you take a popular resource and advertise the BGP route from the origin to tier 2 and tier 2 to tier 3, when that next hop goes along, it's as far as the tier 2 is concerned, the next hop is the origin. As far as the tier 1 is concerned, the next hop is tier 2. So a request comes into tier 1 requests the content from tier 2 all the way up to the origin. That'd be a popular content example. In the case of unpopular, maybe tier 2 says, you know what, that content's just not that popular. Instead of setting the next hop to myself, I'm going to leave the next hop as the origin. So when this tier does the route lookup, who's advertising it to me? It's actually the origin, and I won't bother asking the tier 2 for that. And I can do that completely dynamically. I can change it whenever I want. So if things start to get unpopular, I can tell the CDN, stop using that tier. It's a waste of your cache. And then maybe later in the day that gets popular again. I can say, okay, now you start to set it the next hop to yourself, and now you're in the flow again. So you can do all this very dynamically. So if you want to do this, you have to figure out how to associate things with IPv6 addresses. And there's a bunch of different ways you can do this. And they can interoperate too. You don't have to pick just one. The easiest, and I'll get back to that in a second, is just direct resource to address mapping. And what that means is I know how to take a URI and change that into a v6 address, which is the simplest. Everyone can do it. Our servers could be able to do it. Even clients could be able to do it. However, it does mean everyone in the industry has to agree on how that mapping works, and that seems pretty impossible. Also, there's only so many bits, so you run out of the ability to do this at some point. So while it's the easiest, it's probably not the one that would win. The next model is a mapping service. So you can almost think of this like DNS, except instead of asking for a host name, I'm just going to give you the entire URL, and you give me back a v6 address. So if I'm Charter, I would operate one of these services. There'd be an API. Someone could come and say, hey, I'm looking for this resource. Here's a URI. Give me back a v6 address. And that means Charter is now responsible for doing that mapping with any semantics that they want. You as the requester don't care. You don't care how it did that conversion as long as it did that conversion and handed you back a v6 address. So there's a lot of flexibility there. However, people would have to run one of those servers. So that there is some trade-off there, and we have a picture of how that works here. So if a client here wants to get file I want.jpg, it obviously has to do a DNS lookup to get to the edge node. Nothing changes there. That's the way it works today. But when it gets to the edge node says, ooh, I want to map this to a v6 address. So it goes and asks the mapping server. Mapping server spits back an IP address. Edge node then uses its routing table to do a lookup to figure out who's the origin that's advertising reachability to that resource. So the left side of this works exactly like CDNs work today. It's only once you get into the CDN that some of this magic starts happening. The last one on the slide is getting into actually encoding file names as v6 addresses. So rather than file I want.jpg, I have v6 address.jpg. So that removes the need for this mapping agent because you're directly encoding that data into the name. So same process on the left side, gets to the edge node. Edge node says, hey, that looks like a v6 address. I'm going to do a route lookup. And now I know which origin to go to. So if you can get to a point where you're actually starting to name things as v6 addresses, it gets a lot simpler. Then we have Nirvana, which is getting to a point where all of that routing information for content and resources is actually exposed to the IP network. Everything we've talked about so far, all that routing information is limited to the CDN nodes. There's actually, there's routers and stuff in the middle here that are completely ignorant to this right now. If we can get to a point where we can start advertising that reachability to the network, now the network is armed with the information to make the right routing decision. And there's two versions of this. One is for v4 and one is for v6. So the v6 model is pretty easy. The client could look at the request and say, that looks like a v6 address to me. Instead of doing a DNS lookup and figuring out how to get this edge node, I'm just going to set that IP as the destination IP in the packet. So there's no more DNS involved in this. You're actually routing based on the name of the file. That is your destination IP address. That gets the router. The router says, oh, you're looking for this IP address? Then everything we just talked about happens. It'll do a forwarding decision based on that destination IP address, forward it to the edge node. Edge node will do the exact same thing, figure out who's advertising it, and off you go. So now we've started to expose that resource routing information to the network itself, and now the network is an active participant in this resource routing design. Of course, we have to account for v4 compatibility, things that aren't v6 enabled. So in that model, we still have a DNS server. DNS server would give the CDN host name. It'll forward the packet out. Now in this case, the destination IP address is the edge node because it can't do v6. So we can't set a destination IP to a v6 address. It's still a v4 address. When it gets to the router, if we were able to get routers to do this, look down a little bit further in the header and say, hey, wait a minute, that looks like a v6 address. What if instead of forwarding it to the edge node by IP address, I do a route lookup in my content routing table? Now the router is still doing the same thing it was doing before and using the v6 to route the packet. It's just pulling it out of the HTTP header or whatever instead of actually forwarding on the IP address. So there's lots of things you can do here to start exposing that data to the network. And once you've done that, now the network is actually forwarding your content request based on content, not based on IP address. It's actually based on the content address. Ooh, come on, there we go. So this is basically a summary of the last few things we've gone through. Because I'm running a little bit slow here, I'm going to move past this. This is just a summary of the last few slides. So why is this important? Why do we care? Depends on what you're trying to solve. CDN overlay efficiencies. So CDNs are today classically overlays. It doesn't participate with the network. The network doesn't participate with this. The CDNs are making decisions on layer 7. IP networks are making decisions on layer 3, so they're kind of at odds with each other, and there's always going to be suboptimal routing when you're doing that because the content lookup decision making is separate from the IP forwarding plane. Yeah, okay, that's that. Resource affinity is another one. So right now, there's no data-driven form of affinity. We have hashing, and hashing works great, but there's still no guarantee that the thing you're trying to get that from, A, has ability to get the content you want, and B, maybe even already has that content. If you start advertising reachability to content, now you can be sure that if I got a route from somebody that they have the ability to get that resource or maybe even have that resource. And that also means repeated requests for that same thing will always go back to that same origin. So you get affinity and you're not wasting your cache by spreading it across multiple nodes. Liveliness detection we talked about, you kind of get that for free if BGP is your control plane. And control plane scaling, and this is an interesting one. We've solved the problem of network scaling and route growth scaling, I'll say it like that. BGP's already solved that problem. We have route reflection, we have confederations. BGP's already solved that problem. We can use that right now with this concept and get that scaling concept of control plane scaling fixed right away. So this does mean we have to kind of change what an IP address represents to us. Right now, an IP almost always represents a host or an interface. And to me, a host or an interface is just a grouping of resources. If I can go to that IP address, maybe that server is a DNS server and a web server and a mail server. And what that means is once that request gets there, that device needs to make a decision on what do I do with it. I've gotten this request to this IP address that represents 4 different things. I have to figure out who to hand it to, and that's usually done with TCP ports today or UDP ports. But really, an IP address represents a host. You have to start, for this concept, you have to start thinking about an IPv6 representing a resource, not a host. So rather than having IP address and then port 80, you don't have the port 80 anymore. This IP address represents the host and the port 80. It could be a file, it could be a RESTful endpoint, it could be a block on disk, it could be TCP UDP port, it could be anything you want. As long as it's an addressable thing, you can associate it with a v6 address. In any of these cases, you can throw a CDN in front of them as long as it's something that can be cached or there's value to caching. So you may not want to do that with a TCP UDP port because there's no concept of caching a port. But a file, sure. A block on disk, sure. So it doesn't need a CDN, but it can use a CDN. Some things we need to think about, mixed mode. So if I have a CDN that can do this resource advertisement stuff and a CDN that can't, how do those two interoperate? We still need to figure out customer steering, and we kind of already solved that problem from a CDN perspective. We have smart DNS from Akamai or somebody like that. We can do 302 redirection, so we've kind of solved that problem. The last one's important, commercial relationships. So if I start to think about my CDNs like we've thought about IP networks for the last 25 years, and I need to now start peering with other CDN networks, what does that commercial relationship look like? I'll go back to this one in a second. So there's concept of foreign caching, where I have the client and there's a resource over on another CDN that my client wants to get to. And because of that, I need to get BGP advertisements from that provider. So I have the client, you have the resource, I want to cache your content on my network. So how do I know how to get to your origin? So that's kind of one direction. Then we have local caching. So in this model, I have the resource and you have the client. And I need to advertise you reachability to the resource I have. So it's just the opposite. And this is basically mirroring the way internet commercialization worked out. There was transit, there was settlement-free peering. This is just the CDN analogs of those. And the last one is, I operate a CDN in the middle. I have neither the client nor the resource, but I know how to get to the resource and I know how to get to the client, and therefore I can bridge those two. So I can start re-advertising reachability to this resource that this customer owns. I can re-advertise that reachability to this customer where their client lives. So you can just start to think about this like a regular IP network, and this is how the internet works today, but instead of reachability to a host, I'm advertising reachability to a resource. That's all it is. Oh, flash, perfect. Just on time. Okay, so it's demo time. It's a very simple network, and what I have here is an edge node and two origins, and you can kind of think my client is sitting over here. And we're going to take a moment and pray to the demo gods. Okay, so what we have here is a terminal that needs to be reset, apparently. There, sorry about that. Okay, what we have here is, these are the origin servers, origin 1, origin 2, and this is their traffic load. You can see it's bytes right now, not much. These are the access logs from the two origin servers. This is the edge node routing table. You'll see it's empty right now. There's no routes in it whatsoever. And I have two video streams. I have a ABC family and a Disney feed here. So right now, there's nothing in the routing table, which means go. Okay. Oh, there. As you would expect, it doesn't work because I have no routes in my routing table. So the request is getting to the edge node, and the edge node's going, I can't help you. So what I'll do is, first thing, I'm going to turn up one of my origins and have it start advertising routes. You should see a route pop up there. Cool. So now I have a route. And what that route is a /32. So a huge, huge block of IPv6 addresses. And it's coming from static origin 2. So if I refresh my video stream here, we should start seeing traffic. Go. There we go. So you can see origin 2 is now taking hits, and its traffic level is now in megabytes rather than kilobytes. So it's starting to take that load because now we have a route. And as you can see, the next hop on that route is static origin 2. So this guy's getting the requests. If you look at the access log, you'll see that those requests all look like v6 addresses. So I'm directly naming the files v6 addresses. So what's happening is the request comes into the edge node. The edge node says, oh, that looks like a v6 address. I'm going to do a route lookup. My route lookup says, I need to go get that content from origin 2. So it starts asking origin 2 for that request. OK, so now we have traffic going to origin 2. I'll turn up Disney just in case anyone wants to watch Mickey. That should start in a second. So what you'll see here is there's two prefixes. I have a prefix allocated for ABC, and that's 2001 blah, 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 colon 1. And then Disney here is 2001 colon 2. So two different subnets, one for ABC, one for Disney. They both fit into this large /32 announcement. So I was talking about before how you can aggregate routes. That's what I'm doing right here. Origin 1 is saying, I have the ability to get to both Disney and ABC, and it's telling us that by advertising a large 32 that both of those subnets fit into. The other thing you'll notice, and I was talking about traffic engineering a little while ago, we have a local pref set here. The way local pref works is the higher the local pref, the better the route. So right now I have a local pref of 50. I'm going to turn my origin 1 server on. And what we should see is another route pop up. There's my another route. In this case, origin 1's local preference is 100, which means it's better. And because I turned on that route, we're now seeing that traffic hit origin 1 and not origin 2. So by advertising a route with a better local preference, I've shifted traffic over to another origin server without having to adjust my CDN whatsoever. And you'll see traffic disappeared from origin 2, and it all moved over to origin 1. The other interesting thing I can do with BGP is start advertising a specific. So let's say I wanted to move just Disney over to origin 2. I could add a Disney route on origin 2 and start advertising the specific for Disney. So what I did there was I started advertising the colon 2/0/112, which is exactly the route for Disney from origin 2. So it has a specific for origin 2, and it's using origin 2. We went back to 3 megs here, give or take. We lost 3 megs here because that traffic moved over. For ABC, this specific doesn't match ABC. So ABC is still using the aggregate route, which is coming from origin 1. So just by playing with the local pref and playing with the specificity of the route, I can now start attracting and repelling traffic from my origins at my will. And the CDN doesn't know or care that I'm doing that. It's just doing these route lookups. So that's the proof of concept. It's kind of cheap, but it illustrates the point. So I think that's it. Any questions? So we built a huge analytics engine in-house, but same general premise. But that could drive some of this, right? You could start using that to say, you should start advertising Disney from this node over here, or Disney's having a bad experience, move just that route advertisement over. Yeah, absolutely. If you can get some business intelligence behind this, you could do some pretty interesting things. Yep. So are you guys actually using No. No. We have proof of concept working. We haven't gotten quite brave enough to do this yet, but it does work in the lab and here. No, it's conceptual right now. We're trying to find some partners who run similarly sized CDNs to start doing some inter-CDN versions of this. We're getting there. Yep. Sure. So what I was talking about before. Oh, I'm not in the demo, or I am in the demo. Let me see. Where's my mouse? There we go. So the problem is, let me see, where's the right one? Yeah, it doesn't really matter, I'll show you here. So the problem being, if I'm a different CDN, and this is a client over here, that client still needs to figure out how to get to this edge node. and that may or may not be the best edge node for them geographically. So there still has to be a DNS server that knows you're in Florida, I want to give you an edge node over here. If it's the model where the CDN's actually advertising routes, which was this, yes, this one, where the CDN's actually advertising routes to the network, you almost don't need that functionality for v6 anymore, because the destination IP is the chunk name, so you don't need to do that mapping between a name and an IP address. But in cases where you do, v4 as an example, you still need that intelligent DNS server to get you to this towards this edge node. And something like Akamai or any of those would work. Cool. Should I stop questions? I don't know what to do here. Go ahead. God, those are the two reactions I was hoping for.
Perfect. I'm just kind of wondering, in a operating scenario, how many prefixes do you think you have running around, like inside your AS?
Sure. So it's up to you how granular you go. I don't think we would go past maybe a service like CNN or TBS or a VOD asset. So we'd have a bunch of 112s running around. In our network, that would be 50, 60,000. And then obviously when you start advertising those to other CDNs, you start aggregating. So it would look exactly like the internet routing table today, where on an AS you have a bunch of specifics, and then from the outside view of that there's a bunch of aggregates. But yeah, I mean, you could go crazy and go down to yes. Yeah. Sorry, go ahead.
If you had the mapping of each of every asset, what's actually going to track that mapping? And then, like, let's say you delete that asset.
So there's two answers to that. One is the mapping server if you're using a mapping server. If you don't, it has to be part of your whatever your workflow is that's smart enough to say that asset's removed, we can't serve it anymore, this file's dead, I have to stop advertising the reachability to that. Or you continue to advertise reachability to it and the thing just gets a 404 or whatever it happens to be. But yeah, you have to put intelligence in there. All right, I'm done. I'm told. Thank you.